Hi. In this video, we're going to look at queues. Now, first of all, I want to state that queues are this built-in library in Python that uses queues, and we're not going to do that. We're going to create our own. Best way for you to learn about queues and how they work, rather than just using something that's already there. Yeah, later on when you get out in the real world, you might want to use the built-in stuff and use libraries because it's a lot faster. But right now, you need to learn the underlying ways that things work. So we're going to write our own queues here and use them. So what a queue is, it's an ordered collection of items where the addition of new items happens at one end, called the rear, and the removal of existing items occurs at the other end, called the front. Think of it like a grocery store where you get in line. So you're at the rear of the line. The people in front of you get processed first, and then you get up there. Then the people behind you get processed after you do. So as an element enters the queue, it starts at the rear and makes its way toward the front. The most recently added item must wait at the end of the collection. The item that has been in the collection the longest is at the front. So this is called FIFO, first in, first out. So we're going to go ahead and create the class itself. So get this started here. I'm going to create a blank or an empty file. Go. So class Q. We need to do our init. And all we're going to do, we're going to use a list to structure this and call it items. And it's going to be equal to bracket and bracket for an empty list. And that's all we need in our init. Okay. Now, the actual methods that we're going to use in here, we're going to, and they're called a little bit different than what they were in a stack. We have enqueue, enqueue is to add an item to the rear of the queue. And then we have dequeue, dequeue, which removes an item from the front of the queue. We have is empty to check to see if the queue is empty, and we have size to return how many items are still in the queue. Okay, so let's go ahead and finish working on this here. So our next one is going to be then our enqueue, or I'm sorry, the is empty. And all we're going to do is return self.items or equals bracket and bracket. And it should be two equals or net. So is self.items an empty list is what that's checking there. So in that case, it would tell us that it's the queue is empty or not. So an enqueue, enqueue, self, and then the item that we want to add to the queue. Let's see, why doesn't it like that? Let's try this again. Nope, there's something missing up here. Oh, somehow I got two parentheses on there and it didn't like that. There we go. Okay, so enqueue is self.items.insert 0, item. Now we could do this one of two ways. We could do the enqueue where we do the append, and then we can do the remove from the front end, which would be a pop 0. So either way works. You can do the insert 0 or you can do the pop 0 on there. The enqueue is going to be an ON notation, big O notation ON, because when you insert the item, everything has to be adjusted down one. The dequeue is the remove, so we're going to return self.items.pop, and pop is an O1 because it's removed from the end of the queue, nothing has to be adjusted. So it doesn't matter which way you do it. If you do the append, then it's an O1, but the pop 0 is an ON. So it doesn't matter on that which way you do that. And then the last one is our size. And it's going to just return an int value of self.items. Oops, sorry, length. Did that wrong. Length of self.items. That's our Q class. So I'm going to go ahead and get this saved. And you would think I would save it as QUEUE, Q.py. But if I do that, the problem is that when you do the import, it's going to import the built-in class rather than the one I created. So I'm going to save it as a QU.py. So that takes care of that. So now what we want to do on here is we want to create a test program. So I'm going to do a file open. Oops, wrong thing. Sorry. Do a file new so we can type this in. And I don't need this one anymore. I can open that up if I need to look at that again. But so what we're going to do here is we're going to import our Q, and then we'll do a series of commands to see how this works. So I'm going to from QUEUE, I'm going to import QU. Main function Q is going to be equal to our QUEUE. We're going to print, oops, import Q. Let's see, I did this backwards here. From QU and input QUEUE. We're importing the class from the file. So I'm going to print is Q empty. Okay, we'll see if that's true or not. That should be false. Or I'm sorry, that should be true. It is empty. Then Q.en QUEUE dog Q.en QUEUE 4. And we're going to print just enter two values. So now what we're doing is we're assigning Q back to another Q object. So it's going to erase all this stuff out of here that we just did in there. So if we do a print here, and to print out whether it's empty or not again, it should come back true again because we just deleted out the stuff that was in there because we overwrote it with the new object reference. So now we're going to do Q dot NQ of 4. And do it again for dog this time. And then we're going to do one more. True. We're going to check out, see what the size is after we added those three. Check again to see if it's empty, which in this case it's not empty, so it should come back as false. Okay, add another one, and then we're going to do some removing. Okay, so that's just to test all the different methods that we have in there, make sure that all this stuff works. I'm just going to call main this way, and I'll go ahead and get this saved. qu.test.py, so we can save that on there, and then we'll run this, see if I got any errors in here. Yep, there's one. Right here, there should be over one, and then a comment in between there. I missed that. Okay, let's run this again. There we go. Is Q empty? True. Just entered two values. Is Q empty is true because we reassigned it. Remember that on there? Size after adding three items is 3. Is Q empty is false. We removed the 4. We removed the dog. Remember when we added those in, they entered them in 4, dog, and so on. And now the size is 2 because we have true and the 8.4 in there. So hopefully that gives you some background on this. But now what we're going to do, I'm going to go ahead and do this. Open up a new window here. Is we're going to go ahead and do a small test program on this. And the program we're going to do is called Hot Potato. I don't know if you ever played that game. It was a game that we played when I was real little. You actually didn't use a potato at the time. You just used an object, and you usually got in a circle, and then you passed the object around the circle, thinking that it was a hot potato. Okay, so you want to get rid of it as fast as you can, and then you played music or something, or somebody would be the organizer of it, and at a time they would say stop, and whoever had the potato at the time had to leave. Kind of like a cakewalk or musical chairs, same type of thing. So we're going to simulate that in a program here using a queue. So from QU, import our queue, and we're also going to import random so we can get some randomization to this program. Create a function called hot potato, passing in our name list that we'll create in main. So we're going to do a simulation queue, going to be equal to our queue there. And then we're going to do for name in for name and name list simq.enqueue name. Okay? That gets all the names into our queue. So then while simq.size is greater than 1, we're going to play the game. Num is going to be equal to a random dot rand int 1, 10. So that's going to tell us how many times we're going to pass this around before it stops. So each time through this, for I in range num, simq dot enqueue simq dot dequeue. And what this is doing is we're going to do this more as a line than a circle. So what happens is that we remove, we remove someone from, they just pass the potato off. So we move them from the queue, and then we add them back in the queue so they run around and get back on to the back of the line again as it gets passed back around. Okay, so that's how we're simulating this on there. Okay, so then once we do that, that's when it ends, and then so then whoever has the potato, they would be at the end of the depending on which way you're looking at it, at the front of the line on that, So then we do a sim q dot dq to remove them from the line. And then once we run through all of these, okay, then we're going to return simq dot dq because there should be one left. DEQ U U E U E U E U E DQ. Okay. So let's do our main. We're going to have names is going to be equal to, and then we'll do a list here. Bill, Mary, Sally, John, Martha, and Larry. And then we're going to call or print hot potato, passing in names. Okay. So let's give this a run, see what happens here. Oh, we got to save it first. File save as. It would ask me that anyway, but potato.py, and then see how many mistakes I did. I'm typing this in. Nope, didn't do anything. I got Bill as the person who won the game. Okay, let's try it again. Mary won that one. One more time. And we got John. Now, if we wanted to see this a little bit better to know actually what's going on here, to print out who's getting out and everything, right here we could do, I'll do person equals sim q.dq, and then on this one sim.nq person, and then here I can do a print person. So that'll list all the ones that got out, and then the last one printed would be the winner. So I can put that on here. Print there. Okay. So let's run this, and then you can kind of see what I'm talking about on here. So here we go. There's all the names, which didn't really work right because Mary, Sally, yeah, maybe it did. Mary, Sally, John, Martha, Larry, Sally, John, Martha, Larry, Mary, Sally, see, Larry, Mary, Sally, Martha, Larry, Mary, Martha, Larry, Mary, Larry, Mary, Larry, Mary, Larry, and then Mary was the winner. Okay, so you can see that the names go down one at a time as it goes through here, on there through the for loop. And the other thing that we could do is right here, put in a print. We'll run it one more time here real quick. There. So you can see the breakdown on it now. So it ran through Bill, Mary, Sally, John. And then Larry, Bill, Mary, Sally, John, Larry, Bill, Mary, Sally, John. And then, so if you notice here, okay, then we got Bill, Mary. This is because of the random numbers being larger and smaller and stuff. Bill, then Mary. And then John, Bill, Mary, John, Bill, Mary. And then Bill was the winner. Okay. So it kind of gives you an idea of how it works and how the queue works on there. So hopefully this kind of helps you a little bit with queues. Bye.